Hey, what's going on, you guys? My name is Chris Givens, and today I'm excited to share with you the fascinating world of electromagnetic waves, exploring their unique presence in nature and our everyday lives, and how they relate to something we all love and experience, daily music. Electromagnetic waves are forms of radiation that travel through space, carrying energy from one place to another, and are a fundamental aspect of the universe. Move on to the next slide, okay? So what are electromagnetic waves, right? Let's start by understanding exactly what they are. So these waves are categorized by their wavelength, which is the distance between successive crests. A familiar example of these waves in action is sunlight, which is crucial for photosynthesis in plants. Other daily examples include the microwaves in our kitchen, and even the rainbows we find after a rainy day. All of these are manifestations of electromagnetic waves affecting our world in beautiful and useful ways. Moving on to the harmony and electromagnetic spectrum. Just like musical instruments that can play the same notes but sound different, uh, thanks thanks to their unique timbres, electromagnetic waves are also have distinctive properties. For instance, while radio waves are essential in broadcasting and communication, microwaves are used in cooking and radar technology. Mm, This diversity in application highlights the unique roles each part of the spectrum plays in our lives. The electromagnetic waves around us. So electromagnetic waves surround us in various forms. Sorry, I was getting some water. Microwaves heat our food by exciting water molecules. Radio waves keep us connected through communication. X-rays peek inside our bodies without surgery. Infrared technology is used in remote controls, and ultraviolet light helps us in sterilization and forensic science. Each type of wave has a specific use based on its properties, showing how integral they are to modern life. Amplitude, okay? Specifically in music, amplitude affects the volume, where a whisper in a library is much quieter than the roaring crowd at a concert. Similarly, in the world of electromagnetic waves, amplitude determines the intensity and brightness of the waves. This concept helps us understand why certain waves are more powerful or more penetrating than others. Now we move on to wave propagation. So for this one, consider a concert hall, right? Where sound waves produced on stage travel through the air, reaching each listener with clarity. Similarly, electromagnetic waves radiate from their sources, filling space and delivering their energy across vast distances. Whether it's the light from a distant star or a signal from your cell phone, these waves seamlessly carry their music to the universe's vast audience. Cool. Before I talk about this one, I just want to say I do appreciate the feedback I got from my peers, the ones who were to like grade my work essentially. I took in consideration all of, the everything that you guys said, and I thank you for that. Um, that being said, I did refine this presentation based on you guys' feedback, and it helped me clarify the between musical instruments and electromagnetic waves. I've even added specific examples and enhanced the visuals to make these abstract concepts more tangible and relatable. drawing up clear parallels between sound and electromagnetic waves, and aim to provide a more engaging and informative experience. In conclusion, we've explored how understanding electromagnetic waves through the lens of music can enrich our comprehension of both science and art. By paralleling musical instruments with sources of electromagnetic waves, we visualize how these phenomena operate in the real world. Live demonstrations using musical instruments showcase waves in action, bringing the harmony of the universe waves to life. As Carl Sagan said, science is a way of thinking much more than it is a body of knowledge. With that being said, my name is Chris Givens, and thank you for